Welcome to this presentation on the Interreg Europe project Zero CO2. And in this presentation, we are going to take you through a PESTEL analysis of how current energy efficiency promotion policies in Malta can help promote energy efficiency and what are the main drivers that could enhance them today and in the coming years. Damien Gatt will be presenting this presentation, and I will be commenting every now and then on certain aspects of it. Thank you.
Hello. It is important to note that these slides are also available on eSurgeGate, for which you can download and also go to. Firstly, we have to mention the current policies promoting energy efficiency and use of renewable energy sources in Malta. There are currently three basic policies. One is the promotion of renewable energy sources, which are the photovoltaics. The second one is a grant scheme for domestic solar water heating. And the third policy is the promotion of financial instruments on energy efficiency, basically for roof insulation and double glazing. We will start by describing the promotion of renewable energy sources, the photovoltaics. Currently, there are two options for this policy. Option one is a feed-in tariff for 20 years, and the second option is the feed-in tariff for 6 years plus a grant on the capital costs. And this is applicable, option two is applicable for the residential sector only. The target sector are residential and non-residential building, structural integrated and rooftop installation. This policy has been ongoing since 2006, although the grant limits and feed-in tariff rates have been changed over the years according to PV market pricing. The foreseen funds are as follows. The funds assigned from the operational program 2014-2020 are 140 million for the +1 megawatt system over 20 years lifetime, 6 million per annum for the less than 1 megawatt systems, and the 33 million for the feed-in tariff scheme, the residential. The following is that this is an interesting exercise where we went to different entities and we have put together the funds that have been used so far for this scheme. The capital grant scheme for residential buildings issued by MLA and DOs was a total of 39.1 million euro paid from ERDF between 2010 and 2015. The ERDF 2007-2013 capital grant schemes for non-residential buildings issued by the Malta Enterprise accounted to 11.4 million euros that were given as grants to industry and commercial entities for investing in energy efficiency and renewables. The PPCD, the capital grants issued by PPCD for various EU-funded projects under both OP 2007-2013 and OP 2014-2020 amounted to 2.8 million euro. And the feed-in tariff expenditure for PVs was 2012 3,041, 2013 5 million, 2014 until 5 million, and 2015 7 million. Now we are going to start looking at a PESTEL analysis for this promotion of renewable energy sources. From a political point of view, the strengths are as follows. Solar energy is predictable, and Malta has the highest solar resource in Europe. The implementation of many small-scale PV systems is easy, fast, and requires minimum permission procedures. Increased security of supply thanks to PV installation. Measure has also been successful from an uptake point of view. From an economic point of view, the feed-in tariff rate changes according to prices of PVs on the market. From a social point of view, it is easy to estimate payback period, so there is little investment risk, and energy generation benefits are seen immediately by the owner. Scheme is also relatively simple to understand, From a very good initiative and on a more grand scale, a government-led initiative for 2016 has seen the introduction of communal solar PV farm for 1 megawatt peak or less that is planned to be built on top of large water reservoirs and specific land of low environmental value. This scheme has given the opportunity for residential households with no access to rooftops to benefit from PVs. The scheme has been fully subscribed and households had the opportunity to invest up to the limit of 3 kilowatt peak. From a technical point of view, PVs have little maintenance, there is little technical preparation involved, they are relatively easy to install, energy generation is easy to forecast and is not so much subjective. From an environmental point of view, there is substantial reductions in CO2 emissions, and they also contribute towards achieving the renewable energy target for 2020. From a legal point of view, installation regulations from a planning policy impact point of view are defined in this DC15 and are being regulated. The Electricity Network Code governs electrical safety and other networking standards, whilst the Malta Competition and Consumer Affairs Authority has issued best practice standards for PV installations.
As a result, I would say that the market of PV in Malta has increased from a few kilowatt peak installed in 2010 up to 80 megawatts and more by the end of 2016.
Now we will look at a PESTEL analysis, but for the weaknesses or for the gaps of this promotion of renewable energy sources. From a political point of view, energy efficiency measures, in addition to PVs, should also be given priority and support. PV market still cannot grow independently as it needs support, which comes from schemes linked to annual national budgets and funds available under the EU operational programme. From an economic point of view, measures that incentivize energy demand reduction may be more economically beneficial if properly implemented. The overall investment in PV capacity is still expensive. By the end of 2015, Malta had approximately 75 megawatt peak, up from a negligible capacity in 2010, which has costed around €160 million in total to installed. But they still only produce 4% of the total primary energy consumption of Malta. From a social point of view, there's a visual impact of PVs and the rebound effect of households that may end up consuming more electrical energy, given that they have installed PV systems. And also, PVs do not bring as much non-energy benefits such as thermal comfort as passive approaches, such as insulation would bring. Various authorities are involved when applying for the installation of solar systems and feed-in tariff, which calls for the introduction of a one-stop shop. From a technical point of view, this promotion of PVs does not follow the energy hierarchy of reducing energy demand first and increasing energy efficiency prior to introducing renewable energy. Electrical load balancing may become an issue in certain areas due to high concentration of PV installations. From an environmental point of view, energy demand reduction and energy efficiency not prioritized, which is more beneficial for the environment. From a legal point of view, solar rights are not being protected. There's a youth ownership landlord-tenant issue. And from our point of view, PV planning installations requirements to minimize visual impact may have become too stringent, which may impact PV installation and generation potential. These are some suggestions which we are looking for, which one can suggest for improvement. Any future government communal solar farm projects could be extended to households who cannot install PVs due to shading. Solar rights should be better protected, but implementation in practice is complex. PVs alone won't enable one to reach the near zero CO2 targets. A bundle of approach policy scenarios, including energy efficiency measures, should be adopted. One interesting approach would be to mandate the cost savings from PVs to be used to increase energy efficiency for envelope and equipment of inefficient buildings that benefit from feed-in tariff. The issue of load balancing should be better tackled. A one-stop shop for policy application and technical advice service to the general public is highly recommended, and bundled PV and solar thermal schemes may make more sense for households. Now we are going to the second policy, which is the GRANT scheme for domestic small-scale solar water heating. The target sector is only residential. There is no scheme for the non-residential. It has been ongoing since 2006. The foreseen funds are approximately €0.25 million per annum, and the funds used so far approximate 3.5 million by the end of 2015, all from national funds. We are going to look at a PESTEL analysis for the strengths and weaknesses of this policy. From a political point of view, investment in new solar heating system has seen a constant decline over the past few years. No major intervention is planned to rescue this technology from dying. The current scheme has not changed in conditions or in monetary value, even though the price of solar heaters has slightly increased over the years. There is conflicting use space between PV and solar water heater, which has resulted in this decline. On a positive side, solar heaters occupy less space than PVs to produce the same amount of energy. From an economic point of view, PVs are regarded by the public as being more financially attractive than solar water heaters. The solar thermal generation effectiveness is linked to demand-supply matching characteristics. Some allow demand for hot water, and it is not easily measured, which makes people less convinced of the true savings. From a social point of view, payback period is more difficult to estimate than PVs, so there is a higher risk in investment. No alternatives are currently provided, such as air-to-water heat pumps for the public who do not own a rooftop. And alternatives would require investment in a distribution network infrastructure. From a technical point of view, solar water heaters reduce demand for energy, and just today, the only renewable energy source that can economically store energy and reduce evening peak loads at the power station. It requires more technical preparation. More detailed sizing is required, not a one-size-fits-all solutions. More maintenance are required than PVs. Energy-saving benefits are more difficult to forecast. It is a very mature technology, however, inferior products exist on the market. From an environmental point of view, substantial reductions in CO2 emissions if solar water heaters are properly sized and managed. From a legal point of view, the impact of new planning regulation as published in DC 2015, whereby solar panels cannot be higher than 1 meter above roof level or otherwise have to be installed horizontal, would jeopardize the prevailing and cheaper thermosiphon solar heating systems. Solar rights are not being protected. Use sharing is not always possible. There are also landlord-tenant issues. Here are some suggestions for improvements. Grants should not be limited only to solar water heaters for hot water, but should also be provided for heat pump water heaters, especially for dwellings with no rooftop access. The grant value for solar heaters is to be revised upwards, given that costs works associated with solar heating installations are significantly high. Increased training to installers to correctly size and install solar water heating systems is very important. Increased awareness should also be given to users as how to best manage the use of solar water heating to ensure maximum savings. The initiative by the Energy and Water Agency to provide free energy efficiency support to households can be enhanced to promote this awareness. Bundled incentives for PV and thermal systems whereby households can benefit from specific grants when purchasing a bundled system rather than PVs only. A cost-benefit analysis should be performed to provide a grant that better incentivizes this technology. A study to incentivize solar water heating and heat pump water heaters for commercial buildings such as hotels and restaurants should also be considered. The last policy is the one promoting financial instruments for energy efficiency. It covers roof insulation and double glazing and specific for the residential sector. It has been ongoing since 2006. There are only 50,000 euros per annum in 14 funds, and the funds used so far are approximately 350,000 by end 2015. These are a PESTEL analysis of the strengths and weaknesses. From a political point of view, the current scheme has not changed in conditions or in monetary value, showing little incentive to progressively update support measures. From an economic point of view, the eligible costs are only for double glazed glass pane, but not for the frame or the label costs. Studies have shown that dwellings have typically 5 to 15% of total external walls made of glass. The grant aims at retrofitting of glazing in existing residential buildings. Existing homes have flat concrete use without insulation. The FVG value is 2 watts per meter squared Kelvin, so there is possible improvement to the, at least to technical guide F U value, which requires a minimum U value of 0.59 watts per meter squared Kelvin. Government offers a capital cost grant for insulating existing use to bring them to equivalent requirement of new buildings. However, the eligible part is only for the insulation material and not on the other necessary work such as label, top roof, concrete, finishing and waterproofing, while the cost of insulation material is only 10 to 15% of the total cost for renovating rooftops. From a social point of view, public may not be aware of these incentives, as publicity for renewable energy and efficiency measures from companies who sell green products is mainly only on PVs. Public is also given the wrong message that double glazing is one of the most important energy efficiency measures for buildings in Malta, while a number of local studies have shown that other factors such as shading and insulation of single walls are more effective. From a technical point of view, various studies have shown that double glazing should not be high on the priority list for energy savings given Malta's mild climate, with shading of glazed temperatures being more effective in promoting thermal comfort and improving energy efficiency, while also insulation of single walls is more effective, given that more buildings have over 60% of external walls being single. From an environmental point of view, potential to reduce emissions by installing double glazed windows is low, mainly because Malta's climate is mild and there is no large temperature difference between indoors and outdoors for most of the year. These are some suggestions for improvements. Policy should be revised and research studies consulted to promote the highest energy savings for building first, based on scientific evidence. The building stock should be well studied and the most suitable and effective package of measures, not single measures, should be incentivized for the different building types. This is required to ensure deep energy retrofitting to each NZEP targets. Now we are going to see a case study of a public building which has used some of these policy measures in order to retrofit the building to zero energy. This presentation was presented in the EPPD, which was held in Malta. It can also be found on YouTube in the link shown in this presentation. Okay, this project was carried out by the Energy and Water Agency and supported by the University of Malta. This is the plan layout of the school. Basically, the school has orientations in all directions, north, south, east, and west, with a courtyard in the middle. There are classrooms facing each orientation. The building was modeled using a software called Design PESTEL, which functions on the popular Energy Plus engine. For the building envelope, as one can see, the design software gave us that shading is required in order to achieve thermal comfort in summer. And so, as one can see, on the east and west facades, vertical external shading was implemented, which is automated by the BMS system so that it moves with the solar path. And vertical shading was used because it requires to trap the low-angled sun on the east and west facades. Thermal insulation was also used on some of the classrooms to check its effectiveness for the Maltese climate. And on the south facade, okay, in order to protect the building from solar gain during the summer, PVs were used. These PVs act as overhangs while at the same time generating energy. As one can see on the right picture, this is taken from during the summer, as the PVs are shading the glazing during the summer, while in winter, because the sun is lower, it can penetrate the glazing. And the PVs on the wall generate approximately 1,100 kilowatt hours per kilowatt peak, versus a normal rooftop systems, which rooftop PVs were also installed, would generate approximately 1,600 kilowatt hours per kilowatt peak. So using PVs, we are getting the best of both worlds. We are shading the glazing on the corridor, and we are also producing energy. There are also unglazed solar absorbers in order to heat the pool, since only a small temperature difference is required to heat the pool. Unglazed solar absorbers are a more economical and economic technology in order to heat the pool. And so these were used and coupled. They were coupled with an water heat pump system in order to heat the pool efficiently. The school has a very comprehensive building management system. Okay, lighting is also managed by a dial system, which allows the light to be dimmed so as to save energy when there is sufficient daylight in the classroom. The lighting is also interlinked with the shading system, with the movable shading system, in order for the shading to be optimized according both to daylighting, temperature in the classroom, and according also to the solar path diagram. Occupancy sensors were also installed in the classroom to manage the lighting and the infrared panel heaters. As one can see, before the school was refurbished, portable heaters used to be used. They were 2 kilowatt peak, 2 kilowatt heaters, 2 kilowatt convective heaters, where only the teacher used to be comfortable with the environment. Now, thanks to the infrared heating panels, which are 97% radiative, these panels are installed on soffits, and with only 2 kilowatt peak, 2 kilowatt, all the class is heated. Okay, because this technology heats directly the students and the teacher, not the air. So, using less energy, the thermal comfort is satisfied in the whole classroom. Another interesting technology that was used was to implement mechanical ventilation using demand-controlled ventilation through CO2 monitoring. Before this mechanical ventilation was installed, in order to ensure the indoor air quality, the classrooms used to be opened during the winter period, and so there used to be large cold air entering the building, and which it used to reduce comfort. Now, thanks to mechanical ventilation, the teachers can keep classroom closed during the winter, the heat is trapped inside the classroom, and indoor air quality is ensured, and it is always ensured, okay, through CO2 monitoring. The ventilation rate works according to the CO2 level in the classroom, and it always makes sure that it's within the AN standard limits. Another technology which was installed is due to the same mechanical ventilation is night purging, when the BMS senses that weather conditions are favorable. It senses whether conditions are favorable via a weather station which is installed on the roof, and it measures the outside weather conditions and compares them to the inside temperatures while thermometers are installed inside the classroom. This is basically a very interesting concept of a sun space. Okay, basically here it is the courtyard is south facing. We have a corridor and the classroom. Since the corridor is south facing and it has a high glazing ratio, while the classroom is north facing, the corridor has a 2 degrees or 3 degrees higher temperature than the classroom. So we can make use of that change the temperature difference during the winter by transporting the heat from this corridor to the classroom. Here we have shown the temperature difference between the classroom and the corridor. There's a temperature difference of 2 to 3 degrees. Okay, and how does this work? Okay, basically the mechanical ventilation exhausts air from the classroom, creating a pressure difference. Okay, and when this pressure difference is created, hotter air from the corridor goes through this inlet grill. Okay, it inputs warmer air into the classroom, and so it reduces the heating load required by the infrared heaters, thus promoting a passive technique to energy saving. Also, as one can see, the roof has PV panels, while the walls have PVs, and also solar thermal absorbs solar thermal are installed on the south-facing facade. The pool also, since most of the heat losses occur due to evaporation of the water in the pool has an automated polycarbonate cover which provides 50% savings of the pool. The pool at the school is the main energy consumer, consuming around 50% of total energy consumption. So the cover is a very important energy saving measure. So the school, we are currently looking, these measures have been implemented for about 1 year. We are currently going through the data of the building management system in order to optimize the system and see which measures are the most important for the such school and which are the most economically feasible. So once we get this data, we can have a prototype of how best to implement energy saving measures in school buildings. But we are sure from the initial readings that the school is a zero energy building. And here are some of the most important measures that were installed: external shading, mechanical ventilation, infrared panel heaters, LEDs or Wi-Fi fittings with use of prisms and detectors, renewables, a highly sophisticated BMS controlled for optimal energy efficiency and comfort, and also an enhanced building fabric. All these improved energy consumption and also thermal and visual comfort in the school. Thanks for your attention.
Just as a concluding remark, we can see here from this presentation that schools in Malta, number one, are not air conditioned. And therefore, one has to try as much as possible use natural systems and avoid the introduction of air conditioning systems in schools. Secondly, schools are not only for students, but it's a place where also families see and talk about these energy efficiency improvements, and therefore the general public will be interested to implement some of these measures in their own homes as well. And the final point about this school is that although this was a holistic project, it could happen, and this is to be expected, that certain measures might not be cost effective today, while others are. And within the course of studies at our institute, we will be identifying the most cost effective measures and recommend them for other schools in the near future. Thank you.